In 1994, physicist Dr. Miguel Alcubierre formulated a novel solution to Einstein's field equations that determined that there is, in principle, a way to create a faster-than-light warp drive possibility that physics at least does not prohibit. It may not be practical, but as it stands right now, it is plausible. But the idea does not tell you how to create such a drive, which means it probably should not be called the Alcubierre warp drive. A better term sometimes seen is the Alcubierre metric. Rather, it just gives a framework for it consistent with Einstein's field equations. It is something you could plausibly do if you can figure out how, or even have a way to do so. Essentially, what this involves is contracting space in front of your spacecraft and then expanding it behind you, which should allow one to exceed, perhaps even greatly so, the speed of light, because the action here is not the object riding the wave in the warp bubble, which remains technically stationary, but the action of space-time itself, which is not beholden to the speed of light rule. This works on an assumption, however, that you can create an energy density field that is less than that of the vacuum, in other words, negative mass, which the universe does not prohibit either, but we have no idea how to make it, at least in the form we would need. More on that in a bit. This is also a problem for the same reasons, for stable artificial wormholes and traversing black holes and so on. We don't know how to make the stuff we need for that, if indeed the universe provides a way to actually make it at all. But there are now glimmers of hope here, in that it might. Interestingly, this isn't the only trick within the work of Einstein that provides a potential hack to traveling to other star systems, and even galaxies, very rapidly, well within a human lifetime. General and special relativity allows it more conventionally as well. You just go at near the speed of light. You need energy for that, but it comes with another cost, and that cost is severe future time travel. Say you wanted to travel to the Andromeda Galaxy and you accelerate at simply 1g, eventually reaching near the speed of light. Then halfway through the journey you flip around, and then decelerate, and the result is you will reach Andromeda in 28 years in your frame of reference. The problem is, once you stop the ship, you change frames of reference and find yourself in the distant far future from your original time you left your planet. Everyone you ever knew, even your own civilization itself perhaps, is in the distant past, and you are alone. This is because of time dilation and length contraction in relativity, and the problem with it is that it would require enormous amounts of energy to accelerate a ship loaded with 28 years worth of supplies. It's more than the output of the sun in a year, so only a Type 2 or higher civilization can do it. And they still can't defeat the time travel reality. So the only fix here is do not care about ending up in the far future from where you started. Aliens may not care though. AI machines very likely would not. Yet we humans, at least some of us, might. But that is only because of what it means to be human. For something else, the rules may change. The Alcubierre warp drive avoids that because you aren't actually traveling. The bubble of space around you is, and it's not nailed to these rules, and actually allows you to go even faster than near the speed of light. Actually, at this point, there is no known upper limit on how fast an Alcubierre drive can actually go. There may not be an upper limit, and you might be able to travel to the other side of the universe nearly instantly. You need a huge amount of energy to get this going, but it suffers from the further problem that we currently have no idea how to slow, steer, or stop an Alcubierre drive. We do not know how to bring it out of warp once you are there. Bring us out of warp, says Captain Picard, is a lot harder in reality than Star Trek made it seem. It's worth noting, though, that there is a hint that negative energy density may be possible and may exist in the form of the Casimir vacuum, which is negative energy density, through the observed Casimir effect. So there is a possibility there that we've actually seen, but it's unclear if it can really be applied. But it also pays to bear in mind that general relativity is incomplete. And it may be that a quantum theory of gravity, should anyone ever be able to cook one up, may close the loopholes of the Alcubierre drive, or indeed any idea that allows for backward time travel, which indeed the mechanisms of the Alcubierre drive does also imply that. We just don't know. It's just that anything that goes faster than light comes with a baggage in that it is also capable of being a backwards time machine. But you're going to need more than 1.21 gigawatts and a DeLorean to do any of this. The energy requirement is titanic, at least the mass of Jupiter at this point. But there is a rather strange aspect to all this that has recently come to light as scientists have thought carefully about the idea. So imagine a high-energy particle traveling along at some fraction of the speed of light, and all of a sudden, an Alcubierre warp ship comes along, and this will happen. All of space is full of particles. It will sweep that particle up and carry it along, and in doing so, increase the particle's energy. And the longer your warp journey lasts, the more particles you pick up. And it turns out, because of relativity, there is no upper limit on the amount of particles you can pick up. The bottom line is that when you stop that warp bubble, those particles all go flying in a cone in the direction of your destination, irradiating it in the best case scenario. Do not point the front end of your Alcubierre warp drive ship at an inhabited planet, because when you come out of the warp, you will hit it with high-energy particles and gamma rays to the point you will cause the extinction of all surface life present on that world. But since there is no upper limit, you could release enough energy to instantly vaporize an entire star system. And that's where we get into the spooky territory, because there is a reason why you might actually do precisely that. It's all starting to sound like a superweapon. More on that in a bit. Incidentally, for more on the Alcubierre drive, see my interview with Dr. Alcubierre on Event Horizon, link in the description below. But you also have the additional problem of generating quantum effects inside the bubble. The edge of the bubble is a horizon, which means that it's thought it will produce Hawking radiation inside the bubble. This is such a problem that it may simply collapse the warp bubble the instant it's created, yet still kill you if you are inside the bubble. But if the drive proves to be possible but deadly to life, you still have a weapon if you just send an unmanned warp ship. This would not be like an artillery shell, however, because the space inside the bubble where the warp ship is not moving. Thus the ship has no kinetic energy. It's the radiation front, which at this stage in the game is capable of being an all-powerful weapon with no apparent upper limit on how powerful it could be. You may be able to obliterate a star with this, wherein there is probably a technosignature hidden there that we could detect. Another question would be, what if an Alcubierre metric ship that was cooking along at superluminal speed hit a planet? I have not found a consistent answer to this question other than it would somehow punch through and carry some particles with it. But with no actual kinetic energy involved, it remains very unclear. Interestingly, however, unlike most speculative ideas in science, the Alcubierre possibility has actually been strengthening of late, instead of weakening as more thought is put into the concept. For example, the energy requirement used to be presumed titanic, all the energy of a star. But new thinking on the geometries of the warp bubble have reduced this significantly, though it remains very high. And the one really problematic part of the idea, the requirement for negative mass, now has a second indicator that such a thing actually is possible to make. This comes in the form of a superfluid recently created that is a type of Bose-Einstein condensate, where individual atoms move in lockstep as a single object, like one big atom. Interestingly, another hypothesis actually posits that such a material lies at the heart of ultra-cold neutron stars, so may actually occur in nature. This superfluid is mysterious, so Newton's second law of motion, if you push an object like kicking a ball, it will move away from you. Very intuitive, since we live with that rule every day of our lives. Except scientists knew that there was a loophole, where under the right conditions, the exact opposite could happen, where you push on an object and it exhibits negative acceleration and pushes back when you apply pressure. In a sense, that is an exhibition of negative mass, and this superfluid does it. Negative mass is exactly what you need for things like Alcubierre drives, stable artificial wormholes, anti-gravity, and many of the most fun speculative science possibilities. There has also been hints of something mysterious like this going on in systems where light travels through a non-linear material that has certain specific electrical properties, even some types of crystals. And lo and behold, these experiments would sometimes show a fingerprint of negative mass. The problem is it's not very consistent, and it's uncertain what conditions are allowing it, how to control it, or even where to predict it will occur. It's just something that pops out of some experiments that looks like negative mass occurred, or if it's just that something is somehow being mistaken or misunderstood in the experiments. In any case, without repeatability, not much can be done there. Negative mass is strange. We don't know much here outside that it would be strange, but it allows things like a negative gravitational mass particle to interact with a positive one repelling, yet the other is attracting, leading to the two particles chasing each other off into space at what should be at least the speed of light eventually, but from very little energy needed, or even potentially beyond it. And here things get very strange indeed and very tachyonic. These FTL particle pairs would be particles traveling with each other backwards in time towards the Big Bang, if they can indeed do this in practice. I suspect there is something to prevent this that we aren't aware of, but it isn't clear right now what that would be. And there are other issues that have been raised with the drive. One odd effect is that no matter what, the drive may force tachyonic behavior. This means that if you travel to a distant star, say 2,000 light years away, faster than light with a drive, you may end up reaching it before 2,000 years, meaning that someone would potentially have had to start warping space ahead of the drive, building the highway, before your journey began. As is usual for time travel, this creates a paradox. Paradoxes like that tend to suggest that there is some prohibition against it that we aren't aware of. Perhaps quantum effects, asserting as in Stephen Hawking's chronology protection conjecture. I do have to wonder though, developing an Alcubierre warp drive, whether it's a starship or a weapon, seems inherently dangerous, with a lot of things that have the potential to go wrong, perhaps too many, and that the development of this specific technology may represent a great filter in that we see no alien civilizations because the allure of faster-than-light space travel outweighs prudence, and that no civilization achieves it because some aspect of its development invariably causes the extinction of that civilization. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently addressing those asking why there was no Science News 10 list for this month. I simply ran out of time due to the holidays, so the next one will be in early January, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.